extraterrestrial life exist? This is a question that researchers have devoted much effort to finding an answer to. But so far, the results have been a complete zero. With no clear evidence of extraterrestrial life found. This outcome has led scientists to pose many questions. People look back at Earth, the blue planet teeming with life everywhere, and wonder what created this lush green world. After many research projects, many scientists believe it might be thanks to Earth's ionosphere, which contains three main components. These are the source of organic molecules, the biochemical foundation, abundant energy sources, and a liquid water environment, allowing dissolved chemicals to react with each other. If life on Earth was created from those factors, what about the celestial bodies in the solar system? Are there any places that possess similar factors to Earth? The answer is yes. The solar system doesn't have just one, but up to 4 different celestial bodies, all promising places for life. So, which celestial bodies are they? Let's explore together. The solar system. The solar system is known for its 8 major planets, along with dwarf planets, moons, and countless other small celestial bodies. Among all the celestial bodies, only Earth is the one known to have life as of the present moment. But besides Earth, there are 4 other celestial bodies considered highly potential for the development of life. Here is the list of those 4 celestial bodies. First, Mars. Mars is the 4th planet from the Sun, and one of the most Earth-like worlds in the solar system. A day on Mars lasts 24.5 hours, nearly equal to a day on Earth. This planet also has ice caps at the poles, which expand and contract with the seasons. Researchers have always believed that, in its early days when Mars was young, it once had an environment quite similar to Earth. At that time, Mars had a bigger atmosphere than now, with abundant water on the surface. Additionally, because this planet has a significant axial tilt, about 25.19 degrees, it can create seasons similar to those on Earth. The considerable similarity between the 2 planets has made Mars one of the most promising planets for extraterrestrial life. The belief in life on the red planet became even clearer when signs of liquid water, methane gas, and organic materials were found there. In 2018, the European Space Agency's Mars X-BRED orbiter detected that the ice cap at Mars' south pole was sinking and rising. This suggests there might be liquid water hiding beneath the frozen ice layer. By 2019, NASA's Curiosity rover detected a large amount of methane in Mars' atmosphere. This discovery is very significant because sunlight reacts with methane and breaks down the gas molecules within centuries. Therefore, detecting methane at present means this gas has only been released recently. Methane is important because on Earth it's produced by biological processes of microorganisms. However, the true origin of methane on Mars remains unsolved. In September 2020, another team of scientists using the RARA locator instrument on the Mars X-RED spacecraft scanned an area of 250 by 300 kilometers around the South Pole region. This is the area suspected to have subsurface lakes on the red planet, and they concluded there are 4 subsurface lakes hiding beneath the permafrost. The largest lake has an area of approximately 20 by 30 kilometers. Additionally, there are 3 other lakes with smaller areas, about 10 by 10 kilometers. They are separated by dry rock ridges, isolating these smaller lakes from the main lake. Not only discovering liquid water and methane on Mars, NASA's rover also detected organic material there. Organic material, or carbon-containing molecules, are still considered by many as the first building blocks of life. Discoveries of organic material on Mars have increased during Perseverance rover's exploration of GZERO crater. After 21 months searching for traces of ancient life, NASA's rover has collected half the planned rock samples, some containing organic material. Although none of these materials are definitive signs of life, finding them means scientists are searching in the right place. Currently, Mars has a very thin and dry atmosphere, almost entirely carbon dioxide. This provides little protection from solar and cosmic radiation. In our understanding, through images sent by exploration rovers, Mars appears like a dead planet, only rocks, gravel and dust. If the red planet has managed to retain some water beneath its surface, it might still preserve ancient life, or even life still existing there. But we have no way to explore beneath the subsurface lakes, so scientists cannot yet definitively answer whether Mars has life. Moon Europa was discovered by Galileo Galilei in the 1610s along with 3 other large moons of Jupiter. Europa is slightly smaller than Earth's moon and orbits the gas giant at a distance of 670,000 kilometers with a period of 3.5 days. Starting from the mid-1990s, scientists have studied Jupiter and its satellites. Europa's main composition is silica and it may have an iron core. Europa's surface is a vast expanse of water ice. They believe beneath that frozen surface lies a vast subsurface ocean, possibly up to 100 kilometers deep. As subsurface ocean exists the extraterrestrial life we. At the dawn of the space exploration era, people imagined all life ultimately depended on energy from the sun. The icy moons of outer planets didn't seem like places for any kind of life to develop. But when scientists explored life at Earth's ocean depths, they found that in areas without sunlight at the ocean floor, simple life still thrives using energy from hydrothermal vents. Europa might be similar, where simple life forms could be discovered at the bottom of its subsurface ocean. Europa's energy comes from the combination of its elliptical orbit around Jupiter and its gravitational interaction with 2 other moons. This combination of gravitational forces causes Europa to experience tidal gravitational changes with each orbit, making it flex and release heat, preventing water from freezing. Biochemically useful elements on Europa could come from asteroid impacts or from deep within the moon's rocky core. Humans have only approached Europa with spacecraft flying past this satellite's surface. Nevertheless, Europa's remarkable features make it one of the celestial bodies with the highest potential for life in the solar system. Currently, many ambitious projects choose Europa as their destination. For example, Europa Clipper is expected to reach the Moon in the early 2030s. Additionally, the European Space Agency has approved development of the icy Moon Explorer JUICE, expected to reach the Jupiter system in 2029. These 2 new missions will pave the way for more in-depth exploration to investigate whether Europa is truly suitable for Earth-like life. Like Jupiter's Europa, Enceladus is a world with an icy surface. It has a diameter of about 504 kilometers and is a relatively small satellite of the solar system. In 2005, the Cassini spacecraft repeatedly detected giant water ice plumes, erupting from tiger stripe fractures in the satellite's south polar region. They have counted more than 100 such water plumes. Some of the ejected material falls back to the surface as snow. The remainder escapes into space, forming material in Saturn's E-ray. Scientists are very interested in this phenomenon on Enceladus. They believe there is a massive subsurface ocean hidden beneath the icy crust and rocky core of this celestial body. The detected methane gas could be due to microbial activity in that subsurface ocean. This is the first time Enceladus has been considered a world capable of supporting life. Water is not only present in the plumes but also contains many organic molecules and small silica particles. These could only form if subsurface ocean water comes into contact with the rocky seabed at temperatures of at least 90 degrees Celsius. This is strong evidence for the existence of hydrothermal vents on the ocean floor. They could provide the necessary chemicals for life and a local energy source. Thus, Enceladus has gathered all the necessary elements for life: liquid water, organic matter, and heat. The habitat on Enceladus might be similar to that of submarine volcanic ridges on Earth. There, microorganisms have been discovered that absorb hydrogen or CO2 and release methane or sulfate salts. Life under these conditions doesn't need solar energy, only heat from the celestial body itself. With all these factors, Enceladus will certainly attract attention from future exploration projects. Let's wait and see. 4. Saturn's moon Titan. Titan is Saturn's largest moon and the only moon in the solar system with a significant atmosphere. It has a thick orange cloud layer containing complex organic molecules. Titan's atmosphere is mainly nitrogen, 94%, with the remainder being methane and some other substances. Previous observations have discovered rivers and lakes containing liquid methane and ethane. And there may be ice volcanoes, erupting liquid water instead of lava. This suggests that Titan, like Europa and Enceladus, may have liquid water beneath its surface. At Titan's distance from the Sun, the surface temperature is about -180 degrees Celsius, too cold for water to exist in liquid form. However, the chemical richness on Titan has led to speculation that life forms with different chemistry could exist there. Let's wait and see how scientists decode Titan. So today, Tot2V and you have explored 4 promising worlds for extraterrestrial life in the solar system. Wishing you an enjoyable video viewing. Now, please choose the video on the left or right of the screen to explore more cosmic mysteries with Tot2V. See you in the next videos. Goodbye. Subscribe to the Gian Migo channel so you don't miss exciting videos.